So we want to start each day with a bit of a keynote speaker to just kind of set the overall stage around the topic. And so we've asked Andrew Gill, who is actually, I believe, his evening, from the Center for Environment, Fisheries, and Aquaculture Science to kind of join us. And for about 15 minutes, and I think Andrew has a presentation, really just kind of set the stage for what really is going to be a full day today around ecosystem effects. And tomorrow will be socioeconomic effects, and we'll have a different speaker to open that conversation as well. So Andrew, welcome. I'm going to turn this over to you and thank you for joining us.
Thank you very much. I'm just going to share my screen, and by doing so, you should start to see presentation, I hope.
We see a presentation and
you can see it, can you?
We can see it well, and it's just in, it's actually obviously not yet in full mode. So
it's not in full mode, okay. So just while I get this into full mode, I just want to thank you very much for everybody putting together this workshop, for the opportunity to talk to you. It's a really important and timely topic, as we've heard from other speakers today and last night as well. And when we're thinking about this, the topic of offshore wind, ecosystem effects, and in the context of fisheries and offshore wind and the sort of state of the science, part of this could be a sort of a summary of lessons learned from Europe. But I think that really what would be better, and the way I've sort of set this introduction, this keynote up, is to try and get you to think, to everybody on this call, it's great to have so many people interested, but try and get us to think about what are the general concepts that we've been trying to deal with, where have we got with some of them, and really trying to get us all onto the same page. And this is the information, the detail that we need to drill down into will actually come from the sessions that are following. So I really just want to give a kind of exercise some of the grey matter, wake it up for you guys on the other side of the Atlantic, and for us guys, and give us a bit of a poke whilst we're having our afternoon tea.
Andrew,
so,
that's terrific. I think we're seeing your presenter view and notes. So why don't you go off screen? Lane can actually share your slides, and then you can look at your notes. So if you'll
okay.
And then Lane, that's great. And then Lane will put up the slides.
Okay, next one then, please.
Can you see those? Great. And you can just let her know when to advance. Thank you.
Advance, please, yeah. Okay, so the ecological system and offshore wind. So what is it we're trying to talk about here? So we're thinking about a system, and we're thinking about the system in the picture here. We have our fish that are part of the system, the natural system. We have humans in terms of the fishing boat here is part of the system, and we have fishermen on the end on the turbine, and we have our turbines as well, which are creating a sort of a change to the ecosystem. So what we really want to be thinking about is what is the system, what is currently there, so how is it and how does it change itself? What are we already doing within that system that might be in some way influence that ecological system? And then what are we about to do to change it? And that's the wind turbines. So can you just press, go ahead, next. Okay, now, interestingly, I've been working in this arena for nearly 20 years now. That's what the grey hairs are on my beard. And last week, as part of a floating offshore wind workshop, I heard this quote: "The current interest and activity in developing floating offshore wind represents a real opportunity for all of us to work together to understand the potential for net gain, particularly for the future larger fresh floating offshore wind developments." Came from an industry representative. Now, this is really interesting because this is the kind of stuff we talked about when we were first putting in fixed turbines in European waters nearly 20 years ago, or 15 to 20 years ago. And I can illustrate what's happened with that if you just keep pressing the button, please. Okay, so the idea here is that they're saying net gain. What is net gain? Well, net gain is about the ecosystem. And using my favorite toy here, Lego, I just want to try and illustrate what is it we might be trying to do, because breaking down the component parts could be really the sort of at the heart of how we actually understand changes to the ecosystem. So net gain, so obviously an anthropocentric term, but in the top layer we've got this is a forest, so this could be our marine environment, and we come in and do something. In this case, we have a bulldozer, and then we create something. In this case, a building. And we've lost that forest, we've lost that environment, so it's net loss. What we're really trying to do is have a minimum in the middle, so where we actually can do we can actually interact with the environment, we actually end up with having a similar value to the environment afterwards, so have no net loss. But ideally, if we can, and we have the information to do it, maybe we can go down the route of net gain, which means we have some development, we take account of what's currently there, we then ensure that that is protected in some way, and then we try and make something more out of it and get net gain. Now, this is a relatively new concept, net gain, but actually the components of it and this message that was put across in the quote are extremely similar to the way we were thinking back nearly 20 years, 15, 20 years ago, which is how are we going to work with the ecosystem in order not to create changes that are going to be seen as negative, and there may be opportunities for potential positive gain. Can you just click this next slide, please? So I actually wrote a paper about this in 2005. Now, I could be sitting here getting a little bit depressed that we're still talking about the same sort of things, but actually what I want to do is learn from the basis of what we were looking at there, which was the changes, ecological changes that might occur, and then look at some of the other publications that have come out and some of the other thinking that's gone behind. So if you just press the button and keep pressing, please. Okay, so other people talking about potential benefits to biodiversity. And again, just keep pressing the button, please. There'll be various ones. Okay, environmental ecological effects of ocean energy, learning for monitoring programs, and again, recommendations for the future, energy developments, and thinking about the benefit footprints at different scales. And again, please. Thinking about cumulative effects and how we can use those and support them with marine management and planning. Next one, please. And then linking ecosystem services with biodiversity change and thinking about offshore winds. Next one, please. And even coming out with books, large sort of handbooks, which are trying to identify where there may be some issues and trying to find solutions to them. So all of this has occurred over the past 15, 20 years, and it all has some fundamental basis to it. And that's what I just want to sort of highlight through the next few slides. Next. Okay, and I'm calling this the helicopter approach because at the end of this, I hope there's one thing that you recognize in the idea of the helicopter. And the helicopter is something that we all have to get into. It needs to be a very big helicopter to get over 200 and 300 participants in, but we all want to get into this helicopter and go on a journey, and that journey will allow us to work together to see different perspectives from different scales, and that's really what the helicopter is about. And you'll see that coming into different slides as we go on. So next slide, please. Okay, so a system is really what we're talking about, an ecosystem. I'm going to, in the next few slides, just present some essential elements that based on the reading that we need to be thinking about in order to allow us to understand what the changes may be. Now, what's important here is we have the ecosystem, which is the circle sort of to the left of the center, and it is at different scales. So basically we have the Earth ecosystem, we have other ecosystems, coastal, offshore, deep water coming into it, and then we can go within that, we've got our species that are in that, and then we can look at communities and assemblages. Now, what's really important in this approach of taking a system, looking at a system, is that we are interconnected with other systems. This allows us to think about crossovers with the social system, which you'll hear about tomorrow. Think about governance systems and thinking about how other activities are going on. You press the button, please. So we're going to focus on this one. We've got other things that are affecting us from the outside. It's called the exosystem, but the endosystem, where we are with the ecosystem bits, we are actually, when we're looking at the effects of offshore wind, we are actually going down the scale. You press the button again, please. And again. So within our mesoscale system, we have microscale systems, then we have micro systems, then micro systems. So what that's about is that we're drilling down to look at, say, a species response to a receptor, and that's going to be built within this system. But it has links, and this is the idea of the helicopters. You go up and down the scale to try and get the context, and then look for linkages across in order to try and understand the changes we may see. So we have links to other parts. Next, please, next slide. And there's our helicopter going up and down the system. And again, please. Right, so what can we do to start this off? Definitions, hugely important. What are we talking about when we're thinking about offshore wind and its effect on the ecosystem? This is a framework that myself and George Bowlett, RIP, put together a few years ago, again, to try and synthesize what's going on with the ecosystem. And all I want you to think about is we can define certain things. So the top level, we can define phases of development. The middle levels, we can think about what potential effectors there are, the presence of the devices, noise, EMF. We can think about pollution. We can then think about receptors. And what's key here, the definition of a receptor is not just a species. A receptor is something which can have effect change on it. So it could be the physical environment. It could be a food chain. It could be a species. And that's really important, the definition of that. Then we have effects, how we define effects. These could be short-term, they could be long-term, they could be multiple. And then thinking about how an effect then turns into something with meaningful impact. And we need to be thinking about what the chain link is between these in order to understand what might be determined an impact at the end and what we may need to manage as a pressure at the end of the day. Next slide, please. Okay, next slide. Okay, so slide, please. So time and space. Okay, so we have offshore winds is actually developing at quite a fast pace, unfortunately, in some respects. This is an image showing you changes in the size of the wind turbines that have been deployed. And even the one on the right-hand side is actually small now. That's an 8 megawatt. We're now up in the 12 megawatts being tested. So the industry is moving on. We have different types of designs. We have different foundations. We have floating, we have fixed, we have jackets, we have monopiles. We have different characteristics, and we even have multiple systems that are being proposed as well. We need to be thinking about those. And again, please. And then the organisms that are there. We have organisms that are going to be there, and we need to think about the characteristics that define them. What life stage are they at? How many of them are there? Are they in around the wind farm? Are they not in the wind farm? At what time might they be there? And do they move around a lot, or are they more sedentary? Next, please. So essentially, we want to be asking questions linked to the timing and the scale of where things are. So how many of them are there? Where are they? How long are they there for? How large might they be? And the characteristics, and what else is there? And we could use those questions in a similar way and ask the same about the organisms. When are they there? How long are they there for? So we need to be defining these things. And if we define things, we're drilling down into our system, but we need to be aware that we're trying to drill down to get specific information to then move back up the system, helicopter out, in order to get the context right. Next slide, please. Okay, so here is a good representation of the helicopter approach. We have a single windmill, we have a wind farm, we have multiple wind farms. Essentially, we look at the single windmill most of the time. We try and look at the wind farm to understand things. When we're doing that, we have to be aware that we might be blinkered, which is the bottom picture. So we might be actually looking at a wind turbine, but actually the changes that we're seeing, are they actually relevant, or how do they have some sort of meaning? So we really want to be trying to understand, move between the scales. Next, please. So we want to be moving across so that we actually remove our blinkers. It doesn't mean to say that we can't do the work at the windmills level, but we need to be understanding the context of that change and is it a meaningful change? Next, please. Okay, so the changes that may occur, we can break it down into, these are physical changes. On the left-hand side, we've got before a wind farm, a wind turbine, and on the right-hand side, we have two jacket structures. Press the button, please. So here we might have changes to the physical environment. This is how press it again, please. This is how the changes may occur in things like the current movements, the tides. We may get changes and we end up with a tidal zone. So the structures going in the water will have changes to the physical factors, therefore they may change the species. Next, please. And then we may get a picture on the left-hand side, which is what we might expect to be there already. Press the button, please. And we can look at that in terms of how things are linked in terms of who eats who in a trophic system, or food web, for instance. We can break that down. We can look at the elements. We can look at the predators. We can look at the demersal fish, the benthos, and we can collect data on those, but we're trying to get the system and understand how they're interlinked, which is the arrows. Next one, please. And then we put a wind farm in. How does that change? So basically, all this picture says is there's more links going on. There's differences in the size of the gray arrows, which indicates biomass change. These are kind of predictions that we might expect, but we can go and measure each of these things. Next, please. So then we have the sort of the stressors or the changes. Those changes may be something which could cause a change, which could be deemed negative, or they could be deemed as positive. That's something that we can make an assessment of that to understand what is impact and what isn't. Next, please. And then the different animals will be at different distances away from and so the effects may occur at different distances. And again, this may occur at one turbine, it may occur at more than one turbine. We have to understand that context. Next, please. How do we try and understand that context? Again, drilling down, going down in the helicopter. On the right-hand side, we've actually got what's called a herendogram, which is basically just a mapped out cause and effect pathway of changes that occur in food resource, such as something like a fishery, when we're thinking about changes to the benthic environment. So all you need to see is we can break it down into component parts, we can look at links, and we can measure those things. We could do them by things such as indicators, which are indicated on the left-hand side. Next, please. Those indicators, there's lots of work goes on that. Next, please. And they then come into a framework where we're looking at the cause-effect relations and how they change with the pressure, which might be our wind farm. And then looking at indicators of changes to the ecosystem, maybe through functional change, and trying to relate that to a so what question. And the so what question is something that we see as important to society. It links back to that kind of net gain idea. So the changes to fishery will be societally important. Changes to biodiversity will be as well. Next, please. Just a couple of slides really to finish off to show that we're not doing it right at the moment. This is an evaluation of environmental impact assessments in UK waters, which was done. And essentially we looked at them, and these diagrams are illustrating the bigger the number, so 1 to 4, then the better the information we have. So if you press the buttons, please. So for procedure, the environmental impact procedure is actually, we're not doing too bad. Next one. Looking at spatial temporal components, we're not doing very well, particularly on the temporal side. Next one, please. Things like the baseline, VEC is variable ecological component. We have very little baseline that have been built into these environmental statements. So that's surely not good. We need to know where we are. And next, please. And then looking at cumulative effects, the spider diagram is tiny in the middle. We got very, very little information. So essentially, we're collecting data, but we don't seem to be addressing it in the way that we need to. So next slide, please. And that was central to a publication that we came out with working in an ICES working group, which is this turning off the drip. Press the button, please. And drip means data-rich, information poor. And the idea here is that we're collecting lots and lots of data, but it isn't well focused. We aren't thinking about the proper context for it. And again, please. So basically in relation to marine energy devices, and this was from a benthic perspective, we don't have enough clarity or rigor, so definitions and understanding being clear, a lot of box ticking, and really not actually justified temporal and spatial scales, which give us the meaningful change that we're looking for. Next one, please, the last slide. So essential elements really that I'd love you to sort of keep in mind when we're talking about things in more detail, when we're diving down. Next, please. We need to think about the ecosystems are in a hierarchy with other systems, and they have systems hierarchy within themselves. Next, please. Definitions are really important. And again, just keep pressing, please. The so what, how do we appropriately quantify that? That's a question we need to be discussing when we're sitting in our helicopter. Next. We need to be thinking about questions that are dealing with that so what, and that we target the research in that way. And that will require some intelligence in how we use our monitoring, how we actually collect the data at the appropriate scale and think about the baseline. Is it bad, the baseline, is it good, and how will we utilize it? The system is going to change, and it's already changing now, and it's going to change into the future. So we need to be a bit objective, we need to evaluate things continually, and we need to share the knowledge. And we may end up with a situation, we hope, where we've got everybody working together. And that may be a bit idealistic, but that's the kind of, why not have that aspiration that we can actually work together? And final click, please. And so if you take away nothing but into the discussions, please think about the helicopter. Let's all get on board and talk to each other about this and go between the different scales so we can demonstrate the changes and target the information we need to understand ecological change. Thank you.
Andrew, thank you so much. And we know we rushed you through that, and that was really terrific overview and a kind of a framework for us to be thinking about as we begin to dive into the details. So really appreciate it. And things may come up, and many of your ideas may be kind of reconsidered both at the full scale as we go forward and also at our breakouts as well. So thank you. Really appreciate it.